Good morning, students. Welcome to the statistics class. It's been a long time once again. So now I want to continue the chapter of index numbers. In all the previous classes of mine, I explained to you about all that index numbers, then its types of index numbers, its characteristics of index numbers, its uses of index numbers. And I also explained in the immediate previous class, I explained about the steps in the construction of index numbers. There are 7 steps in the construction of index numbers. These are the things that I have explained to you. Is it right? Yes. So today, let's go ahead further in classification of index numbers. How index numbers are classified. This is very important, students, because once you understand about this classification, writing down the formulae in index numbers is very critical, and that you can understand it very clearly or do it correctly if you only understand the classification which is on the board. Okay, so let me tell you to you in the beginning itself. So as we know, index numbers are of 3 types. Okay, index numbers are of 3 types. I have explained to you in the previous classes. There are 3 types: price index number, quantity index number, and value index numbers. Price index number we denote it as P. Is it right? We denote it as P, price, and P01 we write it as. And quantity index number we write it as Q01, and value index number we write it as V01. Is it right? We know all these things, students. We know these 3 types of index number. P01 indicates price index number, Q01 indicates quantity index number, and V01 indicates value index numbers. Now, price index number, right, it's not necessary that we always have to mention it as price index number. Even if you say index number, it is always referred to price index number. Okay? So only if you just mention index number, it is taken as price index number only, students. But not in the case of quantity index numbers. Right? For quantity index number, the word you should mention quantity index number, value index number. But when it comes to price index number, it's not necessary for us to always mention as price index number. If you mention, fine, it's absolutely fine. If you don't mention, if you only write index number, it always refers to as price index numbers only. So now, whatever classification I am doing in the class today, now will be all about index numbers. That means I will be doing the classification on the basis of price index numbers. Okay? Price index numbers classification. Understand this. So, generally, index numbers are being classified into 2 categories. Generally, index numbers are classified into 2 categories. Number 1, they are called as unweighted index numbers. Unweighted index numbers. And number 2 is called as weighted index numbers. Right? Basically 2 classifications. The index number is being classified into 2 categories. One is called as unweighted index numbers, and the other one is called as weighted index numbers. Unweighted index numbers and weighted index numbers. Now, what is the difference between this? Unweighted index numbers and weighted index numbers. What is the difference between this? Now, when we are constructing index numbers, we have to choose the items. You know it, because we have learned it in the steps in the construction of index numbers, that we have to select the items. Now, when we select the items, we select few representative items, is it right? Which are commonly consumed by the consumers. Few representative items like rice, wheat, dal, sugar, oil. These are commonly consumed items by all people, okay? By all communities of people, these are the commonly consumed items. We cannot construct the index numbers for all the items. It's been told to you. We only select a few items. So when we select a few items, what happens is, in this unweighted index numbers or simple index numbers, we don't consider their quantities. You understand? We don't consider their quantities. we assume that each and every quantity, each and every product or each and every item is equally consumed. Okay, like for example, rice, wheat, sugar, dal. We don't attach any quantities of consumption there. It's only just a prices there. Assumption is that all are equally consumed. All are equally important. That is what it says. All the items that we write are equally important. So we don't attach the quantities there. Whereas in weighted index numbers, yes, all are important, but at the same time we show relative importance, like which is consumed more, which is consumed less. How you can show? It's by the quantities. That means in weighted index numbers we attach quantities along with price, but in this unweighted index numbers only the price of the product or the item will be there, not the quantities. You understand? This is a major difference between unweighted and weighted. In unweighted we only take the prices, quantities are not attached. Assumption is that all the items are equal important. But in this case, yes, we do say all are important, but at the same time we show their relative importance. How much each item is consumed, we will explain that to you. Rice, 25 kgs, the quantity is attached. Sugar, 5 kg, a quantity is attached. That means we can know their importance in every family, right? How much they give importance to one particular item. So like that, when we do it, it is called as weighted index numbers. When we don't attach the quantities, it is called as unweighted index numbers. So in unweighted index numbers also, it has been classified into two parts. One is called a simple average of relatives, and the other one is called a simple aggregative. Okay, number one, simple average of relatives, and number two, simple aggregatives. Okay, in the same thing in weighted also has been divided as weighted average of relatives, and the other one is called as weighted aggregative. This is the major classification of it. Okay, number one, unweighted, weighted. In unweighted, simple average of relatives and simple aggregative. In weighted index numbers, weighted average of relatives and weighted aggregative. So students, in each classification that we have seen, in each classification we come across with different types of index numbers, different formula for index numbers. Okay, now let's go one by one. Let's study one by one. Okay, what is the first sub classification that is being made? It is made as simple average of price relatives. Simple average of relatives. You know, relative or a price relative formula is given as P is equal to P1 upon P0 into 100 students. Is it right? In the last class we have learned that price relative formula is given as P is equal to P1 upon P0 into 100. What is P1? P1 is the current year price. What is P0? P0 is the base year price. I have explained this to you with an example of tomato. P, price of tomato 40 rupees, and P0 is the price of tomato of yesterday, 20 rupees, and based on that I have explained to you, right, about the relative, price relative. So P is the price relative. Now see, price relative is all about one particular item, is it right? Tomatoes, I said. So we only will consume tomatoes in our daily consumption. Do we only consume tomatoes? No, we consume onions too, we consume chilies too, we consume some other vegetables also, is it right? So what we have to do is like that we can find out different price relatives for different items. Are you understanding? For tomato, one price relative. For for onions, one price relative. For chilies, one price relative. Or from any other vegetable, another price relative. Like that, various price relatives we can find out. So I'll define that to be as like this. So for example, I'll take this as P1. Okay, now don't consider this one as current year. P1, this is all about price relatives of onion. P2, price relatives of tomatoes. P3, price relatives of chilies. This is P4, price relatives of any other vegetables. Like this, I'll do it till Pn. n number of vegetables we have. But how do we calculate P? We calculate P using this formula only, students. Price of that particular vegetable at the current divided by the price of the vegetable in the base into 100. We do the calculation like that. For every vegetable we do it, and like that different price relatives we have, students. Is it right? P1, P2, P3, P4, P5 till Pn. So n number of vegetables we buy, and n number of vegetables their price of the previous year and the current year, and we do the calculation and find the price relatives. Okay. Now this is one part. Now let me explain this to you. Taking a little bit in a different thing that if you remember, last year we studied about measures of central tendency. Is it right? You remember this? Measures of central tendency. What are the measures of central tendency? There are 5 measures of central tendency. One is arithmetic mean, median, right? Then what we have? Mode. Then we have geometric mean. Then we have harmonic mean. Okay, forget about all this 5. Let us consider averages. They are also called as averages. Measures of central tendencies are also called as averages. Why am I telling you about these averages? Just because there is a word called average here. Simple average of relatives. Average means, let us think about 2 averages. One is arithmetic mean is one average, and geometric mean is another average. Okay, imagine you have values like x1, x2, so on up to xn. So many observations you have. How do you calculate the arithmetic mean of these n observations? We have very simple formula, and we denote them to be as x bar is equal to sum of all x upon n. Is it right? Sum of all x upon n. This is what is the arithmetic mean. Correct? Arithmetic mean. Then how do you calculate geometric mean for it? The geometric mean for it is calculated as g is equal to antilog summation log of x upon n. Do you remember this? G is equal to antilog summation log of x upon n. Remember this? Yes. These are the 2 measures of central tendency. One is arithmetic mean and one is geometric mean. Now, the same concept is here also, students, applied. When they said simple average of relatives, the average can be arithmetic mean or the average can be geometric mean. You understand? When they said simple average of relatives, the average can be arithmetic mean or the average can be what? Geometric mean, students. Now, average can be average of what? Average of relatives, average of these. Average of P1, P2, P3 up to Pn, average of these, geometric mean of these, arithmetic mean of these, not of x. Only change, if ever I have to compare with this x data and P data, is only x and P is the difference. That's it. So on that basis, based on this itself, the first formula in index number. What is the first formula in index number? The first formula in index number is called as number 1. I'll write it like this. I hope you can see me, visualize me. It is called as unweighted. I can write it this way: unweighted arithmetic mean (AM) index number. Unweighted arithmetic mean index number, students, and it is denoted as P01. When they said arithmetic mean, how do you calculate arithmetic mean? It is sum of all x upon n, but instead of x, what we have here? It is P. So it is sum of all P divided by n. What is P? How do you calculate P? P is equal to P1 upon P0 into 100. Simple. Is it right? This is the first formula that we have it in this index number, which is called as unweighted arithmetic mean index number. It is also called as simple arithmetic mean index number. Okay? So likewise, students, we also have unweighted geometric mean index number. Unweighted geometric mean index number. Unweighted geometric mean index number is P01 is equal to, what is being given here as antilog of summation log x. Instead of log x, it is summation log of P divided by n. Summation log of P divided by n. this is what is geometric mean, unweighted geometric mean index number. This also can be called as simple geometric mean index number, students. Okay, so I hope you have understood this. These are the two formulae that we have. The next one comes is from the next classification. What is the next classification? It is called a simple aggregative. Simple aggregative. Aggregative refers to total. The word called total. Simple aggregative refers to total, students. You understand? Total. Now what is the total? What is the total of? Right, total of all the vegetables. They are current year prices, they are base year prices. Very simple. You buy all the items, right? All those tomatoes, onions, chilies, vegetables, all their current year prices, today's prices with their yesterday's prices. Today's prices you add, it is current year total. Yesterday's prices you add, it is base year total. Simple. So the formula will be like this, students. I will write it like this. P01 is equal to current year total divided by base year total into 100, students, into 100. So it will be like this: current year total means summation, current year price, that is P1, summation P1 divided by summation P0 into 100. This is called as simple aggregative index numbers. Simple aggregative index numbers. Now three formulae. Okay, you understood now? What is the first one? It comes under unweighted, simple unweighted, and simple aggregative. Next one. In simple unweighted there are two. In simple aggregative only is one. Right? Now this is one part. Now comes the next. What is the next one? Weighted average of relative, students. Weighted average of relatives. Again, if we just go back to our PUC first year, and there we have some data regarding the discrete data, tabulated data. Tabulated data is what? I'll just write it to you. Afterwards, I will erase it. You follow it. So how do we have X and we have F? Is it right? We have this is called as the tabulated data. When the values are being represented according to the number of times they are occurred, then it is called as a tabulated data, right? According to their frequencies. So what is how you do calculate the arithmetic mean of this? The arithmetic mean of this has been calculated by the formula as x bar is equal to summation f of x, f into x divided by summation f. Summation f, or we call it to be as, I'll write it, summation f, or we can take this to be as n. Is it right? You remember this? Summation, right? F of x divided by, right, n, or it is summation f. Correct? This is for the tabulated data, arithmetic mean for the tabulated data. Then what would be the geometric mean for it? Geometric mean is antilog of summation, is it right? Antilog of summation f log x upon n. N means summation f. Is it right? This is what we have. You remember this? Right. Just take a nice look about this and remember, because I am going to erase them. Okay, x bar for the tabulated data is summation f of x upon n. And geometric mean for the tabulated data is antilog of summation f log x upon n, students. Okay, now what we should do? The same thing is applied, students. Weighted average of relatives. Now weights here are like frequencies for us. X is P, F is weights. Okay, I'll write it here. It will be like P, it will be like W. So how can we write it here? You only just imagine, and based on that we will start writing it. Okay, let's write the first one. What is the first one? First formula that comes under weighted average of relatives. It is called as weighted arithmetic mean index number. Weighted arithmetic mean index number, students. Okay, weighted arithmetic mean index number is given by this formula P01. how do we calculate it? Is if it is for arithmetic mean for the tabular data, it is summation f of x. F means here, what is f here? That is W weights. X is P. So it will be like this: summation, what it is? WP divided by summation F or summation W. You understood? Summation WP divided by summation W. This is one. Then for geometric mean, how do you calculate geometric mean? That is second one. We call it as weighted geometric mean index number, students. Index number, that is P01 is equal to antilog of, tell me, antilog of, how do you calculate geometric mean? Antilog of f log x, but here will be, what it is some W log of P divided by summation W. Is it right? Correct? Remember, antilog of summation W log P divided by summation W. This is another formula, students. Weighted arithmetic mean index number, weighted geometric mean index number. Now altogether how many formula we have learned? We have learned 5. Okay. Now comes the next one, which is called as weighted aggregative. This I will be teaching you in the next class, students. Okay. See you. Take care. Bye.